Morning, everyone. This is Intro to GraphQL, and as he said, I am Nat. The link at the bottom there is the link to the slides if you want to follow along and click links or whatever. So my name is Nat. My Twitter handle is Ico. I currently work at Google on customer reliability engineering, but this talk is mainly from my experience at First Look Media, which is a media company here in New York. We're going to be talking about, what is GraphQL, why use GraphQL. Some stuff I ran into as being the lead SRE at First Look Media, using GraphQL in production, and sort of just a general current state of the ecosystem because it's changing every day, to say the least. Why am I giving this talk? I started at First Look, and they were like, oh yeah, our backend's completely in GraphQL. And I was like, cool, I have no idea what you're talking about. There weren't a lot of documentation around that time, so I spent a lot of time sort of struggling against my preconceived notions of how REST JSON APIs work versus how GraphQL works. And sort of a lot of my traditional production tricks didn't work, plus I just didn't even know what our front-end developers were doing. So I figured I'd give you at least a little bit of a heads up. GraphQL was invented by Facebook. It's been an ongoing and evolving spec since 2015, but its most recent version is from June 2018, and their opening sentence is GraphQL is a query language designed to build client applications by providing a system for describing their data requirements and interactions. I personally find this very confusing and kind of useless, but technical specifications are usually that way. Another definition I came across and then reworded and have spent a lot of time thinking about, which I think gets closer, is GraphQL is a specification which defines a schema on an API server which validates client calls. For people who have worked with systems where you may have to distribute a schema to a client or something like that, this is slightly different, where the server controls the schema entirely. I didn't find that definition completely there, so maybe another way we could say it is GraphQL is an application layer. GraphQL does not define how data is stored or queried from the source. This is often, when people see the word graph, they're like, oh, it must be a graph database. It is not a graph database. It is an application layer for servicing business logic, not storage logic. Most of my examples here are using my personal GraphQL endpoint. If you wanted to run this empty query, which is, this command is sending a post with an empty post body to this URL, it would return an error message saying that there's no query here. This server is open source, it's on GitHub, but also it fronts a variety of backends, multiple databases, and external APIs. As you may have picked up from that, all of GraphQL is basically JSON. And JSON response to every GraphQL query that you send mirrors each other. And this can be nested as deep as the client wants. This is very powerful, but kind of confusing. Another way to say it is the shape of the request defines the shape of the response, specifically in terms of the data that the JSON is returned. So here we have what I would like to think of as the world's simplest GraphQL query. It is a function called time with no parameters. And it returns a scalar. You know it returns a scalar because there are no curly brackets on the side of it. There is no equivalent of select star or anything like that in GraphQL. So you have to define all of the final pieces of data. So you can imagine this is like running select now in a SQL database or something like that. Its response is just this simple JSON blob. We have the time field that we requested and its scalar value. You can see I ran this at night a few days ago. A more advanced query, only adding one level of nesting, is this post function. I'm passing in a string ID, And I then am evaluating the response, and I'm saying, I just want the title of this post. And the response looks exactly the same in terms of shape. So we have the post, and then we have a title, which is all that I requested. You can see like this shape and this shape, basically the same. And it gets more complicated because, as I mentioned, you can nest as much as you need to. So here I'm calling, there's a related function on the post type. And you can kind of guess from the inputs that I should be getting 7 things back. But instead of specifying an array, I'm specifying how I want the object resolved. So I'm saying I want an ID on every object that's returned from related, and from this post I want related. And that's cool because it then, even though I have many relateds returned, and I've truncated this for your reading pleasure, you just get the IDs of these related posts. I could have also put title there as well, and I would have gotten the title and ID. You can also imagine if this was posts instead of post, it would have returned essentially a n-squared nested array where you have multiple posts, and each one has an array of related. As I was kind of hinting on some of those slides, GraphQL is strongly typed. The schema defines types and object relationships. This is wonderful for people who like types, especially front-end people who are used to dealing with JSON that just comes back and you have to go like, who knows what's going to be in a field? Here is an example of the schema for those past 2 queries. We have time, and it returns a time type, whatever that is, and post, which takes an argument of ID, of type ID, and returns a post. That post type, obviously this is heavily simplified from what you might want in your CMS or something like that, but this post has a title. That title is a string. And then it also has this related that takes in some sort of limit type and returns an array of posts. Time is just a scalar. And in my case, I've written the actual backend code. Time just turns into a string. Scalars in GraphQL just means that it can turn down to a basic JSON type. So either a string or an int or a null or some sort of, yeah, I guess that's it. Oh, I forgot to mention, also notice there is documentation here, which we will get into a sec. This is hugely important for people who have worked with APIs built by random people in their company that are poorly documented. GraphQL includes documentation as a default thing. So you can put quotes around a string above any sort of type, and it will document it. GraphQL has documentation as a first-class citizen. So on top of you being able to, in the schema, write your documentation, there is a default built-in query to GraphQL that returns the documentation of any field as well as the types of that field. Here is one of those 2 types of queries. There's basically it's underbar type or underbar schema. Type is for looking up types. Schema is for looking up schemas. And here I'm just saying I want to know for the type time, I want to know the description. And I send this to the GraphQL server, and it responds with the string that we defined a few slides back, which is great. So now anyone who's working with your API can send queries and be like, hey, what is this thing? If we added some documentation to that post previously, we can both document individual fields as well as the overall type. And then this is really useful because if you are building tools on top of GraphQL that you are giving to your developers, this is a screenshot of GraphQL Playground that is probably very hard to read, but it just has a little tab that you can click, and you click it, and it just opens up with all of the possible things that you can call, all of their types, and all of their documentation. And it got all of that just by querying the GraphQL endpoint. And you can start to see as a client developer why this is exciting, and why if you're in an operational type function, you might all of a sudden have to start supporting this sort of endpoint. Why is kind of, I guess, answered there, but I'll go into it a little more as to how it ends up sort of being built often. Here is sort of your users. They could be developing client applications in just about everything. That anything that sends HTTP can send GraphQL requests. So in mobile, iOS and Android are very common places that send GraphQL. Your browser, I have no doubt that you have visited a media website sometime in the last week that uses GraphQL, or you could even use it on the command line as a way to get documentation or to do things. That would talk to a horizontally scaled GraphQL, like a traditional REST API. It's relatively stateless, so you can scale it as horizontally as you want. And then each of those GraphQL servers will fan out to various backends. Could be databases, internal services, external APIs, whatever. But you provide a unified connection point for the service. This lets your clients be sort of disconnected from your backend development cycle, so your clients can iterate as much as they want. One of my favorite facts about this is Facebook claims that they haven't had to version their API since 2012 because they can continuously update their schema without introducing breaking changes, and all that changes is the fields that are evident in their schema. Also, security is simplified, right? You only have a single endpoint into your backend, so you only have essentially one port or hole to protect. Some sort of publicly visible uses for media companies: New York Times, First Look Media, and Major League Soccer all did pretty large migrations to GraphQL and wrote about it. Mobile apps, both Artsy and Yelp, moved to GraphQL and wrote about it pretty publicly, both specifying how they liked the fact that they could decouple their backend developments and the development speeds of their separate apps, so iOS and Android. And then a lot of companies have also talked about their complex data sets, which are constantly growing and evolving, such as GitHub, Shopify, and Fabric will all have a lot of data and need an easy way for users to explore it. If you have a GitHub account, which is pretty common at a developer conference, check out GitHub's API documentation. They have lots of like click-through examples of where you can just run GraphQL queries against yourself, which is neat. But now on to, I guess, kind of the more interesting thing is the production problems you run into when you're used to classic REST APIs. First off is dumb resolvers. So a resolver in the GraphQL world is the thing that turns any single field that you have requested into some sort of backend call. If every field is a function, and let's say each function resolves a database query, you could easily see someone writing select field name from table where, blah. And then all of a sudden you have one query that's requesting 10 fields, making hundreds of database calls, which you'll see a large performance hit very quickly. So there's tools such as Data Loader and others that on your back end work to unify all of the possible things that your resolver has come up with against a single backend, so you only have to make one or two requests to the backend from your GraphQL server. Unsurprisingly, this can quickly cause fan-out. So instead of sending lots of requests to a single backend, you could have the problem of sending many requests to many backends. This is similar but different because it's kind of hard to solve, right? Like if every backend has a different data set, you can't really prevent that unless you start unifying backends or something like that. So Then it's just monitoring the types of queries. You can instrument your GraphQL service to have, you monitor your GraphQL service so that you know per query or query type which ones are fanning out to which types of backends. And then either rewrite or remove those queries or put some sort of auth in front of them. Query complexity. Some of you may have guessed, based off of the earlier schema, is that if clients are writing arbitrary schemas and the schemas can reference themselves, or types can reference themselves, then you could easily do a query like what I have up here on the right, where I'm requesting 1,000 posts, and on each post I'm requesting the related posts, and then for each related post I'm requesting the related posts, and for each related post I'm requesting the related posts, et cetera, et cetera, et cetera. So it just goes as long as your post body can be large. And you could optimize this to remove the white space and things like that. And all of a sudden, you're getting a request that's like, I need a, n to the n number of related posts, and I'm going to lock up everything until you give them to me. You can deal with this by calculating query complexity, so basically counting the number of depths you go into your query and just putting a hard max. The one thing to look out for is oftentimes GraphQL servers, if you're using a framework or something like that, their schema lookup functions have a high query complexity. So you often have to find that balance between saving your backend service versus providing full details to your developers. Also within that, if your clients can write arbitrary queries to send to you, then they are only limited by whatever post body limits your load balancer or whatever is in front of your GraphQL service have. Here is an example from a real world media company, and if you can't read that, they are sending one request that's over 50K to the GraphQL service, plus two requests, one that's like 2K and one that's close to 10K, just of the request body. And then the response, as you can imagine, since it not only has the shape of the request, also has all of the data that you requested, will get much larger. And so this is a danger, especially if you're used to all of your requests being relatively small, like just a GET request to a JSON API with a header. So there's one common way to deal with this, and that's caching. But it's sort of inverse to what you may be used to. Instead of caching how you're resolving, there are a few services, or a few different ways to write what are called persisted queries. And there, the client or the server pre-computes a hash for the query type. And so all the user has to do is send you that hash, and then the server resolves that into the gigantic query that it could be. You're still going to have to send back a response, because you have to give them data. But this way, you don't have to compute any details about the query, and also you don't have to deal with all of that large incoming request size. Apollo, which is a hosted GraphQL company, has one that automatically does it on the fly for JavaScript clients. Relay, which is a project from Facebook, has one that pre-compiles the queries, and then you have to ship those pre-compiled hashes with your client. Also, you can just do caching in the client code, but that doesn't come for free like it does if you're used to developing web apps, because you are just sending posts and receiving them, so they can't be cached at the CDN, as well as they won't be cached automatically by the browser. So you usually just have to write logic in your client to deal with that. And so at our end, we're just going to talk about the current ecosystem. If you want to get started in GraphQL or just want to understand the words that your client developers are waving their arms about, it's so cool and that you should check out. You may hear the words schema first or code first. These are both just different methodologies for building GraphQL servers. And if you're evaluating frameworks, they'll basically be in one of these two containers. Schema first is you write a schema, and then usually there's some sort of code generation that generates a server around that schema for you. Code first is you write a backend or some code, and then it generates a schema for you from that. Both camps have their opinions. I personally like schema first because I like thinking in API shape, but you know, you're going to run into both out there in the wild. Some interesting projects to look into. There's Apollo, as I mentioned, which is both a hosted GraphQL solution and a client and server JavaScript framework. I really like the client just because they're doing a lot of interesting things to evolve performance solve performance problems on the front end. GQL Gen, if you like Go, this takes a schema and generates an entire Go server for you. It's a great way to start playing around with GraphQL, and it just uses Go's built-in generate function. Prisma and Hasura are both GraphQL companies that are essentially trying to make free well, their products aren't free, but they're trying to make it so they auto-generate GraphQL front ends for a Postgres database or some other type of database. Which is pretty neat if you are a company that doesn't have many or any backend developers. And then some features of GraphQL which I didn't talk about. There's subscriptions, which let a client subscribe to any changes that happen to a query. So you say, I want to subscribe to, let's say, our time query, and every time the server thinks that changes, it'll send you a tick update. Fragments essentially let you share portions of your schema of queries. Unions and interfaces. This is classic things from object-oriented world, which are useful. Thanks. Here's a picture of puppies in case you got bored. That's the link to the slides. I'm Aiko on Twitter. Shoot me a DM if you have questions, or come find me out in the hall. I'll be around all day.